them. Now we'll go over some of the upcoming software features. cnPilot E-Series software release 3.0 will be releasing in August. We'll be starting beta of that this week. Some of the features in that are mesh is being enhanced. So we do have support for mesh. We had released a single hop mesh. Now we are enabling support for multiple hops, so you can extend wireless mesh connections beyond just one hop away from an AP. We've also added an auto recovery feature that allows access points to connect over the mesh link even if one of the APs loses its connection, its configuration. For carrier grade deployments, we've added support for Passpoint, also called Hotspot 2.0. Airtime Fairness is a feature that would help in a lot of dense deployments if there are slower clients, and slower being legacy clients like 11A and 11G in the presence of newer 11 and 11AC clients. We've added support for L2TP tunneling for cases where a customer would like to aggregate all the traffic from an access point onto one concentrator. Another feature that's also part of the 3.0 release is gateway monitoring. We have some cases where an access point where you would want it to serve an SSID as long as a particular device on the network is reachable. So for example, a gateway or a DNS server. And we've also added LDAP authentication for captive portal. So we'll go over all of these features in detail over the next few slides. There's a question on, are we going to cover Passpoint in detail? So we'll go over Passpoint, at least an overview of Passpoint. And then if there are further questions, you can reach out to me and I can respond over email. So the mesh enhancements, we have two major mesh enhancements in the 3.0 release. The first one is we are supporting multiple hops. So the model is still a hub and spoke, so we don't form loops in the network or connections between clients to multiple APs at the same time. But what you can now do is if you have a connection from one base to one client mesh, from that client you can enable a connection to another client beyond that. One thing to watch for when enabling multi-hop mesh is that throughput loss with each hop is high. Anybody down the chain has to first pick up the packets on the same channel from some client and then forward them again on that same channel upstream towards the base. So every packet would end up traversing the air twice, first coming to the client and then going upstream again. So there's a big loss of throughput. It's between 50 to 60% is what we've been seeing in our testing, and this is just the nature of having to first receive a packet and then transmit it in the same medium. Also, if you're using urban environments, because of the interference and the amount of noise that we typically see in urban environments, EPMP, PMP and PTP solutions are much more optimized for backhaul, so we would recommend using that. The mesh hops are mainly to cover an area of your deployment where a cable run is difficult. So let's say you have a Wi-Fi installed in a building and you would like to provide coverage outside in a parking lot. So for short-term, short distance coverage, the Wi-Fi mesh is a good solution. For anything more demanding than that, the EPMP, PMP and PTP solutions would be the right way for wireless backhaul. We have also added a feature called Mesh Auto Connect, which would help an access point that has been misconfigured or if it's a new access point to form a connection back to your network automatically. So if an access point in software version 3.0 sees that it is without an Ethernet link, so this is an access point that has been deployed as a mesh node, it will now try to connect to another AP that it sees in a recovery profile, in a recovery mode. This recovery mode is off by default on your network, so the administrator would enable it whenever you would like to recover an AP that has been stranded. So this would be useful with where you can bring an AP back onto your network without having to say climb up a pole or pull a AP down from the ceiling. It's also recommended when you enable the mesh recovery to have ACLs, so that access on this mesh recovery profile is restricted to CN Maestro, from where you would then connect to this stranded AP and re-enable the connection back onto your network. Airtime Fairness is another feature which is part of the 3.0 release. We see a lot of fast and slow clients, fast being the 11N, 11AC, which can use higher data rates, sharing the same medium with 11G and 11B today. And the slower clients, and the way the .11 protocol works, everybody contends for the medium, and then whoever wins the contention starts to use the medium to transmit a packet. So we see the slower clients using up a lot of airtime and bringing down the overall efficiency of the cell. So one workaround or one solution to this is to throttle the slower clients, and that will ensure some fairness over the air. So what we do is, when you enable airtime fairness, if we see that a client is 11G, 11A or 11B capable, we would slow down the amount of traffic that we send to that client if there is also 11N and 11AC traffic queued up. So what that does is we free up some airtime, and in that airtime where a G client might have transmitted 1 or 2 Mbps, an N or 11AC client in the same airtime is able to transmit a lot more packets. So your effective cell throughput now goes up by anywhere from 10 to 20 Mbps, depending on how you test this. So in general, the recommendation is, if you're still using 11G, 11A or 11B clients, move over to the N and AC as far as possible. Sometimes this is not an option. Example, if you have a public hotspot where you cannot control the client mix, in those cases, airtime fairness can give better experience to the newer Wi-Fi devices. So Passpoint 2.0, from version 3.2, we have also added support for Passpoint. Passpoint is based off the IEEE 802.11 spec, 802.11u. This has also been now set up by the Wi-Fi Alliance as Passpoint or Hotspot 2.0, and they also certify clients, access points and clients for interoperability as Passpoint and Hotspot 2.0, which is a subset of the 802.11u standard. What Passpoint does is it makes the discovery and sign up into hotspots easy. So in the current scenarios, if you were to go to a coffee shop or any urban center and you look for Wi-Fi, you would need to scan for all the SSIDs, find out an SSID that you recognize or that you can connect to, or an open SSID, and then connect to that, bring up a splash page, and then either sign up for service or pay for service and become part of the network. With Passpoint, all of this is automated. What would happen is your phone or your laptop would start scanning networks. It would probe the access points to find out their capabilities. There are some new 802.11 messages added for this. So older access points or access points which are not Passpoint capable will not be able to make use of this feature. So clients use these messages, which are called ANQP and GAS, to learn about the access points. So if they go to, let's say, a Starbucks in some downtown, the client would scan the access point and say what are the roaming partners that access point is supporting, and the access point would come back with a list, for example Verizon or AT&T or Sprint. And then if your phone is capable of Passpoint and if you have this feature enabled, then the access point will then the client will automatically connect to that SSID and set up a secure connection. So that's the other thing that Passpoint brings. Most of the public hotspot today are open SSIDs. With Passpoint, there is authentication involved, and with authentication and encryption, the connection that is formed is secure. Passpoint supports multiple authentication types, various EAP methods. The two most common ones that have been standardized are EAP-SIM or EAP-AKA, which relies on the SIM card in your phone, and EAP-TTLS, which relies on a username and password for devices that may not have a SIM card. So the advantage of Passpoint is just the way in cell phones, when you're roaming from one area to another which is not served by your service provider, your cell phone automatically forms a connection onto the network, figuring out who is the roaming partner. That same problem is now being solved over Wi-Fi. So Passpoint has a pretty extensive network that is needed to make it happen. On the phone side, you need the newer devices. So iPhone 6 is capable of Passpoint 2.0, so is the Samsung Galaxy. Then you need an access point which can answer these messages, the ANQP and the EAP messages that we see on the left side of this frame. So that's where the client device would query the access points. And then back on the network, to terminate the authentication, you need some more additional servers, such as the 3GPP AAA server. That's where the radius authentication happens. And then OSU is an online sign-up server. So Passpoint also has a way for you to sign up if you're not already a subscriber. Another feature in the 3.0 release is L2TP tunneling. There are cases where we have seen where customers would like to pull all the traffic back from an AP onto a central point in the network, and then either firewall it or filter it in some fashion and then bridge it out. So for cases like this, the L2TP tunneling is an option where you can turn all your traffic onto one wireless LAN, onto an aggregator such as a Cisco switch or a MikroTik router. Each access point would form one tunnel back to this aggregator, and then you have a choice on a per SSID or a per WLAN basis whether you would like the traffic to be tunneled or locally bridged out. So for example, all your guest traffic could be locally bridged out, but you could take your enterprise traffic and pull that back onto this aggregator, or vice versa. And what L2TP does is it creates a large layer 2 broadcast domain over L3 in the middle. Gateway monitoring of SSIDs is another feature in the 3.0 release. We have seen cases where, because of intermittent network connectivity issues, sometimes an access point is no longer able to reach the gateway or the DNS server. In these cases, if the access point is still serving up the SSID, you would have the clients connect to the AP but not be able to reach anywhere else on the network. And it might be better if the AP would just disable that SSID temporarily, so that clients roam to another AP where they can get proper connectivity. So gateway monitoring of an SSID would enable that. What you would do is, in any wireless LAN, configure a host, can be an IP address or a domain name, and the access point would periodically ping this device. As long as that device or that IP address is reachable, the SSID would be served up. The moment we lose connectivity to that, we would disable the SSID, and then clients would roam to another access point. So useful if you have a mesh deployed, and let's say the mesh base has gone down, you would like any of the client access points to also stop serving up SSIDs, since even if they can get a client to connect, they will not be able to forward frames for it. When the network goes down, the access point continues to try to ping that IP address, and whenever the ping succeeds, the SSID is automatically brought back up again. LDAP authentication for guest access is also in release 3.0. So we support multiple guest authentication modes today. We support radius authentication. We support click-through for an open network where you would just like the users to accept terms of service. We have seen some cases where IT administrators would like to have bring your own devices enabled for customers, but they would still like to authenticate those users on the guest network. Now, if radius is not an option, then LDAP authentication is a good way to make that happen. The access point would look up Windows Active Directory or an open LDAP server, and the guest users would be prompted for a username and password, and this username password will be authenticated against the Windows Active Directory. If the access point's connection is successful using those credentials, then the device is allowed access on the network, else the device will not be allowed access. So now you can use your same Windows username and password that you use for all your other authentication of your Windows laptops on your network, or of any shared drives or VPN, and you can enable your guest WLAN also on the same, using the same credentials. We also have some miscellaneous guest access enhancements. Given that our focus has been on hospitality, education, the public Wi-Fi sector, we've added some more enhancements in our captive portal solution. We now have a built-in username and password on the access point. For a very small deployment, a separate radius server may not be an option. And there it's useful where if the AP could authenticate the guest users from the splash page, look up their username and password in its internal database instead of having to go out to Radius. So that's an option from the 3.0 release. We also have an option to set the logo and the background image when you use the built-in captive portal. So the cnPilot E-Series of access points have a built-in captive portal where the login message is customizable. What we've now also added is the option to set a background image and a logo, and you'll see a screenshot of this coming up. We're also adding support for social login. So if you would like your users to log in using Google or Facebook credentials onto your guest network, you can now do that. So this is how the new splash page can look, with the option to have a logo and a background image, and then sign up buttons for Google and Facebook in addition to the regular login button. So that covers most of the cnPilot enhancements coming in the 3.0 release. We also have some CN Maestro Wi-Fi updates coming in late August, early September. A quick sneak preview of all of those features. These will be starting beta soon, and we'll do a separate overview of all of these features. But just a quick sneak overview of what's coming up. So we're adding support for a GUI for configuration. Configuration through CN Maestro today involves the use of templates, which have to be hand created templates of configuration commands, and these can be distributed to the APs. We'll soon be able to configure all the WLAN parameters directly instead of relying on a text or a JSON template. So for example, in this case, we have a screenshot of the wireless LAN on the enterprise APs, the E400 and the E500. This is a screenshot of the R series. So the configuration GUI is also being extended to the home routers, the R200 and the R201. And the WLAN policy there is slightly different because the features on the SSID are different on the R series. We're also adding a site. So just the way we have a tower today for the outdoor installs, at the same level in CN Maestro, you'll be able to create a site, add all your access points to that site, and then we will collect statistics on a per site basis. So there was a question on, is access to Wi-Fi via check-in in Facebook available? The answer is no. We're still working on that. In a release in October, we will have an option where you can have an option to log in via Facebook with a checking in. So Facebook has two modes of authentication. What we're adding now is where you can use your credentials to log on onto Wi-Fi, the Facebook credentials that you use. Facebook provides another option called Wi-Fi for businesses, where when you log on to Facebook and you like the business that is hosting that page, then you would be allowed access to that network. So support for that feature on Facebook is coming in the October software release. Another upcoming feature in CN Maestro for site is floor plans. So today, although you can organize your access points in a tree in the CN Maestro hierarchy, having a visual representation on the floor plan is a lot more helpful. So that's a feature where we're adding, where you can upload your own floor plan in JPEG or PNG, drag drop access points on them, and then you can view information about channel distribution, client distribution on that floor plan. CN Maestro will also be able to host your own customized captive portal page, and because this is on Maestro with much more in terms of resources compared to an access point in terms of CPU and disk space, you can customize this page fully. So just a quick screenshot of how a customized page would look when hosted on CN Maestro. So this is a more powerful solution compared to what we have on the access points today. We're also adding support for vouchers, where if you would like to monetize your Wi-Fi or limit access to users, those who have temporary credentials, the administrator can now create vouchers and you can distribute these vouchers to your users. And we'll go over all these features in detail as we get closer to launch towards the end of August. That's all for the presentation today. Thanks a lot for your time. If you have any questions, please go to the questions tab on the GoToWebinar and please enter your questions. So there's a question when CN Maestro would be available for local management. So CN Maestro is now available for local management starting early July. So the NOC version or the on-premises version of CN Maestro has launched now. So cloud was an option until this July. Starting July now, if you want, you can run CN Maestro on your own server. Okay, looks like there are no more questions. Thanks a lot, everyone. Thanks for your time today.